Hi, in this video I'm going to be taking a look at a nice 3.5 kilovolt power supply, which I believe used to power lasers. But I'd plug it in and play with it, but unfortunately it requires a 200 to 240 volt power supply. 200 to 240 volt supply, and I just don't have that right now, and I don't have a wire up to my lab yet, but I'm going to run a line out for that. Cat's kicking the tripod. Okay. Plus also there's an interface at the back I think would be required to turn it on. So anyway, I took some screws out. I haven't opened it yet, but I took some screws out to speed up the process. So let's get on the table and have a look. Okay, now this has all been completely filmed from the flip cam today. My other one's flat, so hopefully the quality is fine. I've got these two remaining screws in here. Alright, let's have a look. I'd say it's very clean in there. I quite like that. Cleanly done. Barely any dust in there. There's a little bit in there. Yeah. Oh, we've got some nice big chunky caps. These resistors. We've got a 7815, so 15 volt regulator there. On a 358, we've got some op amps here, some Motorola chips, ULN 2004, that I believe is a Darlington driver chip. But yeah, that's pretty nice. Look at that. That's a roidal transformer there. Look at that bridge rectifier. That's a chunky piece there. Let's flip it around and have a look. Scratch the desk in the process. Okay. Oh, that's a bit. Some power transistors. That must be some kind of temperature sensor. No, thermal fuse, I believe. Oh, one might be no, it's in view. And some more caps. And there's quite a lot of they're also signified with a D, so those are all diodes. Did they have matching caps to go with it? I can't see any, but I was going to say, because that'd be like a voltage multiplier circuit if it did, which would explain how they get up to the how many volts is this again? I keep forgetting. 3.5 kilovolts actually. I better show it a label a bit. Yeah, don't know if that can be seen, but yeah, 3.5 kilovolts, 2800 joules a second. It also gives 24 volts at 6 amps. So now I tried looking online for any information on this, but I found a couple of companies that stated they could repair it. Well, I don't want to repair it, I want to take it apart. Okay, I'll give it a bit of a close-up look. Got some goodies in there. Okay, I'll take these boards out and I'll come back. Okay, that bit was, I'm pretty sure I'll time-lapse that last bit. But anyway, let's have a look, see we've got a 12-volt fan. That's a very nice case. What I'm planning on putting in here is my dummy load. So I'm going to put this aside for now, the other stuff. Okay. So yeah, there's the toroidal I got off it. It's some chunky beast. I don't really know much about rewinding coils, so I probably won't be looking much into that. Now there's this, some big chunky knock-up coil here. It's yeah, definitely the signature of a very high voltage power supply. Right, and this was the board from, or the second board down. As you can see, these we had screws coming out that I haven't tightened up. Actually, I loosened these to help try and get it out. Turns out that wasn't what was holding it. But yeah, these are perfect. I can put the MOSFETs that I'm going to use for the dummy load on here, and the fan is aimed so it'll suck the air through it. And it's just perfectly positioned for that, you know. And little current sensing thing there. Yeah. And yeah. So what was that? 20,000 K. Oh, so 20,000 ohms. It says in there. I don't know if it will focus. So we've got a bunch of some Dale resistors. 0.05 ohms. So I've got some nice precision resistors. Those will be good in the dummy load for sensing. But yeah, this is a lot of nice stuff in this board. But yeah, I'm definitely going to build a dummy load in here. Okay, this is the bottom side of the top board we saw. Interesting looking transformer there. More current sensing. Some nice caps. Right. That's upside down. Okay. Let's have a nice look at this and see what we got. Yeah. These are MCP 14,000 range chips. There you go, like a little tiny 10-turn pot. Those are the cutest little ones I've ever seen. I don't think I've ever seen them any that small, other than surface mount ones, but very nice. Yeah, good old LM339. Can't have a circuit without one of them. And LM358. Okay, now that one is 7815. Yeah, there's two 15-volt regulators. I only saw the one before. And some nice screw terminals for the but I don't know if I might use them, or I might just use normal banana plugs for inputs. But we will see. That's all part of the later planning. But yeah, this is just the initial first look anyway of this board. I will do a follow-up teardown actually in the lab. There's another 358 down there. Look at those little cute resistors. Yeah, definitely a 20 amp fuse. maybe even good for a dummy load. I don't know how many amps I'll be dissipating, how many amps I'll be loading, and how many watts I'll be dissipating with it, but yeah, that's another story. But yeah, I will follow this up in the lab, and we'll do a proper teardown and take everything out, and we'll have a tally and see what we get. But yeah, I am really happy with those big heat sinks. I wasn't expecting it to be like that in there, but yeah. But basically, I'll get it in here, and it will just suck cool air through it and dissipate whatever load I stick on it. Yeah. Yeah. Okay, yeah, I had a quick look at the chips on here, and I started making a note on the computer. Anyway, so yeah, so that one's a quad comparator, and the 358s are dual op amps, which I'm familiar with those myself. Now, there's where is it? This one here is the UC3825, which is actually a high-speed PWM. So I'm pretty sure that's linked up to that. So I'm pretty sure that's to do with generating the high voltage in some winding somewhere. Now this is an optic coupler, high-speed one, and you can see there's like a gap in the board, so isolating it. And see down here in the logic circuit, there is a bunch of the MC 14,000 range chips. So there's some quad 2 input NORs, hex Smith triggers, dual type D-flops, triple pre-input AND gates, and this here is a ULN 2004, which is a 7 Darlington array. And obviously we know about the 15-volt regulators, fixed regulators. But I noticed on the back, that chip right there, can't get it into focus, I don't think. There's an LM317. You can't have a power supply without 317 on it, it's obligatory. And I like these connectors. I haven't seen these since my old 8-bit days. Yeah, anyway, on this other board, those are all diodes. Figured that one out. But this one here is the UC3854, which is a high power factor pre-regulator. Unfortunately, power stuff is not really my thing, so I'm not entirely sure, but I know the power factor stuff scared the hell out of me at college. I'll leave that to the professionals in that. I'm pretty much a digital person myself, so I don't really care for that. Now, I believe these are MOSFETs, and these are diodes. And I didn't check these ones out, but if they're if any of them are logic level MOSFETs, which I doubt, I may even salvage them to use them as part of my dummy load. But that is one chunky bridge rectifier. I quite like it. Well, I thought that one was quite insightful to have a look inside that power supply. Like I said, this is only part 1 of the teardown. I will be going down to the lab in the next video, and we'll be taking whatever we can off these boards, and then have a good look, and then I'll probably do a new set of videos based on building the dummy load. So until then, thanks for watching, and I'll see you next time. Goodbye.